Okay, nearly there. So question 8. A cup of coffee is left to cool on a kitchen table inside a Brisbane home. The temperature of the coffee at T degrees Celsius after T minutes is thought to be given by the following formula. By how many degrees does the coffee cool in 10 minutes? So we're going to let, for the first part, let T equal 10 minutes. Substituting that into the formula given. Evaluating that on a CAS, we get that that's 77.8 degrees Celsius. Now, unfortunately, I think there was the wrong answer was given in the book. I think they just said something like 7 degrees or something. I think there's a bit of a typo there. The second part B, how long does it take for the coffee to cool to 65 degrees Celsius? This time, we'll let capital T equals 65. So we'll have 65 equals 85 times 3 to the power of minus 0.008 times T. And we can use our CAS to solve. And we find that that is then happens at 30.5 minutes. Part C. Sketch the graph of the temperature of the coffee for T between, or T on the domain 0 to 40. So we should look at that particular formula and realize that again it hasn't been moved up or down. So that just means there's an asymptote where T equals 0. We will need to find the initial temperature. So initial temperature, let T equals 0. So that we have T equals 85 times 3 to the power of 0 when we let T equals 0 in the equation. 3 to the 0 is 1, so it's just initial temperature is just 85 degrees Celsius. And we could actually begin to notice that when we do look at these equations, that the initial value is usually just this this coefficient here. So that gives us the point 0.085, and that's of course the y-intercept. Now we've got some other points that we've already identified. We've got the point 10, 77.8 from part A, and from part B we've got the point 30.5, 65. So I've just plotted those onto a graph of temperature versus time. So I've got the point here 0.085, then the point here which is at 10, 77.8, and I've got 30.5 and 65. Oops, I just realized I've made a mistake with that graph. But we were asked to find the end, and the end point there, of course, should be T equals 40. So I should find that as well. So when T equals 40, we have T equals 85 times 3 power of 0.008 times 40. Evaluate that in the CAS, and that comes out at 59.8 degrees Celsius. So I should probably not have gone past that particular last point when I sketched it in. So I should have ended at 40 because that was the domain that they asked us to sketch it over. And of course I've labelled my axis and my asymptote there. Part D asks, by considering the temperature that the model predicts that the coffee will eventually cool to, explain why the model is not realistic in the home. Not realistic in the long term. So this was a Brisbane home that we were dealing with. So we have an asymptote at T equals 0 degrees Celsius. So the model predicts that the temperature will approach 0 degrees. It's unrealistic, as the temperature should approach room temperature, and it is unlikely that the room is 0 degrees, especially if it's in Brisbane.